Following that snake lemma, let's introduce another famous lemma called 5 lemma. So this 5 lemma is stated as follows. There are 5 columns, 2 rows. Consider the following cumulative diagram in the abelian category. And then the 5 lemma states that if the rows are exact, if column M and P are isomorphism, it is talking about under which condition the middle one is isomorphism. Okay, the question is, can M isomorphism and P isomorphism imply the middle one is isomorphism? The answer is, if L is epimorphism and Q is monomorphism, then this is the case. Actually, this 5 lemma consists of 2 smaller lemma. If you like, you can call them 4 lemmas because they have 4 columns. So the first one, basically, you could think about. Just look at this part. And the second one, just look at this part. The first one states that I'm not asking to isomorphism forcing the middle isomorphism. I'm talking about if 2 epimorphism could force the middle one epimorphism. The answer is it is if this far away one is injective. Similarly, this is telling that if you have 2 injective, one can force the middle one to be injective. The answer is yes if the far away one is epimorphism. And put all those 2 together, you will have this 5 lemma because. So if you ask whether the middle one is isomorphism, you should check separately injective and surjective. So the answer it is injective or not. Use your first 4 lemma. Look at the first 4 columns. So M and P are isomorphism, in particular epimorphism. So the isomorphism in particular injective. So injective plus this far away surjective imply the middle is injective. Similarly, if you look at the last 4, then surjective plus the far away is injective will imply this is surjective, so you can finally prove this is both injective and surjective. Okay, so let's just prove one of it. Let's just look at this. First, 4 lemma, which required that surjective plus injective force the middle one to be surjective. Okay, so let's prove it. To prove this surjective, what do? Start with arbitrary element C. We want to find a pre-image here, right? So what do? Is map it to T of C, let's call it D prime, and then map it to element E prime, which must be 0, because this is composition 2 morphism as a complex is image of kernel is 0. Okay, so this is surjective, so there is this of D, right, which will map to D prime. And so this one must be mapped to what? 0, because what is mapped here by commutative diagram is mapped to 0. And so this is injective map, so this star must be 0 itself. Small commutative diagram. And so Charlie exact sequence implies that there exists some element say here mapped to D. So the first question is they say a pre-image of C prime, not necessarily. So this is mapped to so let's say NC, right? But is this C prime? We don't know. But what we know is that this NC is again mapped to D prime. So you have C mapped to D, C mapped to NC, and C mapped to D prime. At the same time, C prime is mapped to D prime. So this tells that NC minus C is in the kernel of T. And so the image of S. And so there exists some B prime that is mapped to NC minus C prime. Now because this M is surjective, so there exists some B that is mapped to B prime. You got B mapped to B prime. B prime is mapped to NC minus C prime. And now, if you look at this G of B, it will be again mapped to NC minus C prime. No, what I claim now is that what I see with that, in this case, you just select the minus JB. This will be mapped to C prime minus NC. Call this group isomorphism, or you could choose it more. If you don't like that, you could do it slightly differently. You just change at the beginning to change every here just to be C prime minus NC, and then find the pre-image of that element. Because this is again also in kernel, and then you find this B prime to be the pre-image of this C prime minus NC. And then if I pre-image of this B prime to be B, in this case it will be like this. Okay. Why do I want to do that? Because once you got this JB, then this JB plus C, and there you map N. What is it? This is just group homomorphism, and so because at least this is linear, so it would be just the image of JB plus the image of C. That would be C prime. Because this is just C prime minus C plus NC. Cancel C prime. But this one, surely it is in C, because our C is in C and the JB is in C. So we find a pre-image of C. This is just JB plus C. And so we prove that it's surjective.